Okay, the next presentation is by Nefeli Kotitsa. She recently finished the MSc, and for her master thesis she studied the Orthopteran fauna of Crete, about which she's going to tell us a bit more in the presentation. Nefeli.
Which is, okay, forward. This one? Okay. Oh, perfect. Okay. So the pointer is here. Okay. Okay. Which one did you say was the pointer?
The pointer is this one.
Ah, okay. Oops. Hello. My name is Nefeli Kotitsa, and today I will present to you the topic, the Orthopteran fauna of Crete, new data and the preliminary biogeographical analysis. So, Crete is the biggest island of Greece, situated in the South Aegean area. Oops. Okay, here it is. No, that's not it. Where is it? Okay, anyways. And from literature now, sorry about that. Ah, okay, it was there. Yeah, okay. Yeah, from this island, 73 species are known according to literature. So let's start with a brief history lesson on the geological history of Crete. Once upon a time, the whole of the Aegean area was a single landmass called Aegeis. In the Miocene, about 12 to 9 million years ago, it was split in half by the mid-Aegean Trench, which permanently isolated Crete from Anatolia and the Cyclades. A bit later, around 5 million years ago, Crete was also isolated from Peloponnese and the rest of continental Greece. During the Pliocene, Crete was an isolated archipelago of 4 to 5 paleo-islands, which reunited in a single landmass around the Pleistocene. This turbulent history led to the existence of a large number of endemic species. For example, almost 1/3 of the species on the island are Cretan and are endemics to Crete and its surrounding islands. Specifically, there are 3 endemics in Crete and its surrounding islands, mostly Cyclades, Carpathos, Icaria, and Antikythera, and an additional 18 species and 1 subspecies are endemic specifically to Crete. Most unusual is the Eupholidoptera genus, which includes 11 endemic species on the island, confounded in different parts of it. So the aim of this study was the phonistic and biogeographical analysis of the Cretan Orthopteran fauna, which was based on specimens deposited in the Natural History Museum of Crete and the literature up to 2020. We mostly focused on updating the catalogue of species, on the effects of altitude in the Orthopteran fauna, and the biogeographical patterns inside the island. Let's move on to the materials and methods. So we examined the 30-year-old collection of the Natural History Museum of Crete, which led to the identification of about 20,000 specimens. These, as you can see in the map, are covering all the dominant habitat types of the island. Most of the specimens were mostly collected with pitfall traps, with the occasional use of fermenting traps and hand picking. And as a result, there are many ground-dwelling species in the collection. So in addition to the examined specimens, we collected all the published sources and some gray literature up to until that was published until 2020. And if in any case that the altitude or the coordinates were not included in the papers, we would just calculate it using ArcGIS and Google Earth. In order to examine the effect of altitude in the fauna, we separated the island into 6 different altitudinal zones and then calculated the total number of species in each zone. We presented the results using bar charts and regression lines. In order to see the phonistic similarity and patterns between the mountain ranges, mostly in the island, we used the Yakard index and we created a similarity tree based on the UPGMA algorithm. So, what were the results of all this? Firstly, we found 5 species that were not previously recorded on Crete, which are Pteronemobius heydeni, Parabongoblistes novaki, Stenomnemobius gracilis, Rhacocleis insularis, and Rhacocleis antikythirensis. These 2 Rhacocleis species were previously known only from the small islands of Antikythera and Cyclades that are close to Crete. We also discovered the females of 4 Cretan endemics that were previously described only by their male counterparts, which are Rhacocleis derai, Eupholidoptera mariana, Eupholidoptera gemellata, and Eupholidoptera cretica. Also, we discovered the male of the species Grylomorpha cretensis, which was described by its female. Finally, we had some new endemic species on the island. One of them is Leptophies, a species of Leptophies, for which the only information we have for it is these 2 pictures, basically, and the species Eupholidoptera Maria Theresae, and a new species of Grylomorpha. Okay, these are some extra taxonomic notes. I will not stay on them a lot. So let's see the effect that altitude has on the Orthopteran fauna. As you can see here, there is an exponential decrease on the number of species as the altitude increases. This is a very common pattern in Orthoptera and other insect orders. Specifically in Crete, it has been also it was also documented in plants, but in other groups like Gnaphoside spiders and Isopoda, we can see that they basically plateau in low and mid elevations, and they decrease only on the higher altitudes. So what could lead to this exponential decline of Orthoptera species? These are only some examples, some hypotheses maybe, I don't know. The increased habitat variety in lower elevations, the extreme conditions of high altitudes, the higher sampling efforts that happen in lower elevations and especially close to urban areas, and finally the species-area relationship that we all know, which is, especially in Crete, high altitudes cover a much smaller area compared to lower altitudes. Okay, so now let's see how endemism patterns are affected by altitude. You can see here that the number of endemic species is more or less constant throughout all altitudinal zones, while the rest of the species decrease exponentially. This results to the fact that in the lower elevations, in the lower elevations, about 20% of the total number of species is endemics, while when you go to the higher altitudes, almost 60% of the species are endemic. Okay, so you can see similar patterns like this in Coleoptera, in Gnaphoside spiders, as well as in plants, always in Crete. Okay, now let's, now let's see if there are any other patterns inside the island. It looks like the Orthoptera fauna of the lowlands is more or less homogeneous if you exclude some endemic species that are confined either to the west or to the east of the island. But that's not the case for the mountains. Specifically, you can see that the easternmost, the central, and the westernmost mountain ranges are very similar, are grouped together in the similarity tree. This could be a result of the Pliocene Paleo islands that existed, yes. And these islands could also explain the fact that there are some species, some endemics that are confined in the eastern part of the island, some in the western, some exist only on the tops of the mountains, etc. So if we look now at the relationships, the relations of Crete, the faunistic relations of Crete and the surrounding areas, we can see that we can see an interesting pattern. The Cretan fauna is closely related to the Cyclades, which can be seen also by the number of endemic species that these two places share, like the Gracopleis species and the Acrometopa cretensis. There is also a faunistic similarity to Anatolia, which can be seen by the large number of Eupholidopteras that both areas have. On the other hand, it looks like we don't have much of a relation to Peloponnese and the rest of Greece. One example of this is the fact that there are no Greek endemics that you can find both in Crete and the rest of continental Greece. There are only Cretan endemics, South Aegean endemics, and then general East Mediterranean endemics and larger distributions. This is very interesting since actually Crete was separated from Peloponnese much later than it did from Anatolia and the Cyclades. In conclusion, we updated the Cretan species list from 73 species to 78, 81 if you count the new species. We showed that an increase in the altitude leads to the exponential decrease of the Orthopteran species and the increase of the percentage of endemic species in the total number of species. And lastly, that the Orthoptera fauna of the lowlands is homogeneous, whereas the mountains show a clear differentiation between east and west. The Cretan Orthopteran fauna is related to the Cyclades and Anatolia, but not to continental Greece and Peloponnese. These are my references, and I would like to thank you all for your attention. And, yeah.
Thank you very much, Nefeli. What about questions? Oh, we get a tough one.
Thank you, Dragan Chobanov. Nefeli, do you have some hypothesis about explaining this strange biogeographical pattern? Why Crete has more similar fauna to southwestern Anatolia? Is it some kind of faunal transfer through the cyclades, or?
Unfortunately, I'm not really sure yet, but I know that it has been noticed in some other organisms, like the Dentarus beetles, which also follow a similar pattern, but to be honest, I don't know yet.
Okay, and one more question, if anybody has.
There are a few questions online. Maybe you can take a look later to the other questions. I select one from Josip Skeo. Let me see. He wants to collaborate with you on the Adriatic fauna. And there's one, maybe I can ask a question by Michelle Lemonnier. She asks if there is overgrazing in the higher altitudes, and could that be the explanation for the decrease in species richness?
Let me think. I don't know if I have enough data to support this at this point. There is definitely a lot of grazing, but it's more or less constant, so it could be one of the reasons, yes.
Okay, thank you.